So, what if I told you that the same science that could make your sausage healthier could also heal a serious burn or even deliver life saving medicine? I know, it sounds a little like science fiction, right? But it's actually happening right now, all thanks to this incredible material called an oleogel.
All right, so here's what we're going to cover. We're going to take a journey from a problem you've probably encountered in your own kitchen all the way to the cutting edge of biomedical science. And it all comes down to figuring out how to turn a liquid into a solid. So let's start at the beginning. Our story really kicks off with a tricky little problem that affects a ton of the foods we eat every single day. I want you to think for a second about the texture of a sausage, or a flaky pastry, or even a bar of chocolate. You know, that satisfying bite, that structure? Well, that almost always comes from solid fat. In something like these Frankfurters, the fat isn't just there for flavor, it's absolutely critical for holding the whole thing together.
And that's the big dilemma, right? The very thing that gives these foods that texture we love, that solid fat, is often just packed with unhealthy saturated and trans fats. You know, the kind linked to heart disease. So the big question for a long time was, how do you get that perfect texture without the health risk? Well, solving this puzzle required a totally new way of thinking. And honestly, it all comes down to some really clever chemistry. And here's the brilliant solution scientists came up with. The oleogel. Basically, it's a way to take a healthy liquid oil, think olive oil or canola oil, and trap it inside this amazing microscopic 3D network. This network acts like a tiny scaffold, or a cage, that turns the liquid oil into a semi-solid gel.
And get this, you can actually see that network right here. This image is incredible. It's a super magnified look inside an oleogel. It kind of looks like a sponge or even a coral reef, doesn't it? All those tiny little pockets are what's holding on to the liquid oil, giving it all the physical properties of a solid fat. So why does this matter so much? Well, this isn't just theory. People have actually done studies where they replace 100% of the animal fat in sausages with an oleogel. And the result? A sausage with way less saturated fat, but with the exact same texture and structure that people expect. It's pretty much the best of both worlds.
Okay, but the innovation did not stop in the kitchen. Not even close. This is where the story takes a sharp turn from making our food healthier to making our medicine smarter.
You see, researchers started thinking, wait a minute, if this oil sponge can hold on to healthy fats, what else could it hold? They realized its ability to trap things and control how they're released could be completely revolutionary for medicine. And boy, were they right, especially for medicines you put on your skin. Just think about it. Imagine a cream that not only protects the medicine inside, but actually helps it absorb better into your skin and then releases it slowly over time. That means you get a more effective treatment from just one application. And on top of all that, they feel way less greasy, which, let's be honest, is a huge reason people stop using their prescribed medicine. And you don't have to take my word for it. Experts in the field point out that this ability to boost what they call bioavailability is the real game changer. The oily gel helps dissolve fat-soluble drugs and lets them get through the outer layer of our skin much more easily. Bottom line, more of the medicine gets to where it needs to go. And this is a perfect example of it in the real world. This table shows a bunch of different antifungal drugs that are being put into oleogels to treat really common stuff, like athlete's foot, ringworm, even dandruff. It's the perfect use for a system that improves skin penetration and gives you that sustained release.
Okay, but it gets even more exciting. It turns out oleogels aren't just passive delivery systems. No, they can actually take an active role in helping our bodies heal, especially when we're talking about serious injuries like burns.
So for wound care, you basically have two main types of gels. You've got hydrogels, which are water-based. They're great for hydrating and cooling a wound. But then you have oleogels, which are oil-based. They do something different. They form this protective, oily barrier that not only stops moisture from escaping, but it's also amazing for delivering healing, oil-soluble compounds right into that damaged tissue. Now check this out. In a recent study on second-degree burns, scientists compared the two. So after 14 days, the inflammation in the untreated wounds was, as you'd expect, pretty high. Hydrogels helped a bit, they brought it down some, but look at the oleogel bar. The wounds treated with the oleogel had the lowest inflammation by a long shot. And when the researchers actually looked at the tissue under a microscope, the evidence was just undeniable.
The wounds treated with oleogels were just, well, they were healing better. More new skin was forming by day 14. What this all means is that the oleogel created this almost perfect environment for the body's own natural repair process to kick into high gear, which leads to faster recovery and less potential scarring. So, after this whole journey from our dinner plates all the way to the emergency room, what's the big idea we should really take away from all this? I think what this whole story shows us is the incredible power of a single, really elegant idea. By figuring out how to turn a liquid oil into a solid sponge, we can start to solve problems that seem like they're worlds apart. It's a technology that's already making our food healthier, our medicine more effective, and is even helping our bodies heal faster. And that leaves us with one last big thought. We've seen how this technology can transform nutrition and medicine, but what's next? From creating new sustainable materials to delivering probiotics, the potential here is just massive. It really makes you wonder, what other problems out there are just waiting for the right liquid to be turned into a gel?